Assalamualaikum. I am Afiq from Group 10. Our group will present about CO2 storage capacity assessment of the Saline Aquifer in Malaysia. So this is our team, which is me, Muhammad Afiq bin Mohd Sabri, and my team, Muhammad Amir Firdaus bin Ismail, Wan Muhammad Alif, Iman bin Muhammad Shalihuddin. So the content we will discuss about this topic is, firstly, we will discuss about background of this study, identification of potential CO2 storage site in Malaysia, development of the screening tool, method used for quick assessment of CO2 storage capacity, factors affecting CO2 storage capacity, potential benefits of CO2 sequestration of the sedimentary basin in Malaysia, limitation and uncertainties of the study, and the last discussion that I will discuss is about conclusion. So for the background of this study, is driven by the increasing concern over greenhouse gas emission and their impact on climate change, particularly in rapidly developing countries like Malaysia. This has led to a critical need to explore carbon capture and sequestration (CCS) project as a means to mitigate escalating emission by assessing potential storage site and storage capacity for CO2 sequestration in sedimentary basin of Malaysia. So, to identify the potential CO2 storage in Malaysia involve evaluating sedimentary basin based on several key criteria. Firstly, the tectonic setting is assessed to ensure the security of CO2 storage sites. Secondly, the depth and area of the basin are evaluated to determine their potential volume for CO2 storage. Thirdly, geothermal. Geothermal characteristics are examined to understand the thermal condition that can impact stored CO2. Lastly, climate consideration focus on the surface temperature and its influence on CO2 storage stability. Based on this criteria, the top ranked basin for CO2 in Malaysia include the Malay Basin, Central Luconia, uh, Central Luconia Province, West Baram Delta, and the last Belizean Province. This basin have demonstrate high potential for CO2 storage and warrant further detailed assessment for the potential deployment of CO2 sequestration project. So, how they rank the top rank for basin? This they using the screening tool. This method to assess the suitability of the sedimentary basin in Malaysia for their CO2 storage potential. This process involves assigning values to specific criteria outlined in table 1, with each criterion representing different classes ranging from the least to the most suitable. The numerical values assigned here to the various classes for the criteria are presented in table 1. For any sedimentary basin K that is evaluated in terms of its general suitability for CO2 sequestration or storage, the corresponding class J for each criterion is identified from the table 1, resulting in a corresponding score Fi. The function Fi has a different range of values for each criterion, making comparison and manipulation difficult. Hence, the individual score of Fi are normalized according to the Formula 1. The formula number 1, where Pi equal to 0 for the least favorable class and Pi equal to 1 for the most favorable class for all the criteria. This can subsequently be used in the basin ranking process to produce a general ranking score R that later be used in the final ranking using formula number 2 of sedimentary basin of Malaysia, where Wi are weighting function that satisfy the condition. Through compiling data on the established criteria, different sedimentary basin can be systematically compared, contrast, and ranked in terms of their suitability uh, of their suitability for CO2 storage. This quantitative approach provides a comprehensive assessment of each basin's potential role in carbon capture and storage initiative.
Assalamualaikum, my name is Alif. I will continue to present regarding our method used for quick assessment of CO2 storage capacity. The first one, we have ranking of sedimentary basin. By compiling data on the criteria needed, different basins can be compared, contrast, and ranked for their suitability for CO2 storage quantitatively if scores are given for each criterion. Based on the table 1, the table shows the evaluation criteria for preliminary evaluation CO2 geological storage in Malaysia. For the criterion, we have tectonic setting, faulting, reservoir seal, fair depth area, and so on. So it will determine by their score, which is the greater the score, the higher the CO2 storage. And for the ranking sedimentary basin, for the table 2 result, it shows that the highest ranking for sedimentary basin in Malaysia is Malay Basin, and proceeding with Central Luconia Province. The other method can be used for pre-assessment is storage capacity assessment. In this study, theoretical storage capacity of Malay Basin in and Central Luconia Province are determined by using the volumetric method for CO2 capacity calculation in the deep saline formation. The method proposed by the U.S. Department of Energy (US DOE) is intended for external users to produce prospective CO2 resource assessment of potential CO2 storage reservoir at regional and national scale. From the equation, we can there are equation that are used to volumetrically calculate the CO2 storage. So if you see at the table here, you can see that the pink one show that the high potential that can the sedimentary to contain the CO2, and then we go to the slightly yellowish, which is show the average potential, and most of the map show the purple color indicating the low potential, and the gray one show the no potential. So for the storage capacity assessment, the percentage for each potential area are given. The high potential area are 27%, uh, proceeding with average potential area which is 23%, low potential area 30%, and no potential area 20%. For the table 4, CO2 storage capacity estimation based on 50th percentile, Malay Basin and Central Luzon Province show the highest CO2 storage capacity, which is 84 and 56 respectively. The factor affecting CO2 storage capacity in the saline aquifer in Malaysia. The first one, we have the reservoir properties, which is porosity, permeability, thickness of formation. So the higher the porosity and the permeability, the greater the storage capacity of CO2. Next, we have saline water saturation. The presence of saline water in the formation affect the storage capacity of CO2. The higher the saline water saturation, the lower the storage capacity of CO2. Next, we have cap rock integrity. The cap rock is the layer of the rock that overlies the storage formation and acts as a seal to prevent CO2 from escaping. The integrity of the cap rock is crucial for the success of CO2 storage. If the cap rock is not intact, CO2 can leak out of the formation. Next, we have geochemical reaction. The interaction between CO2 and the formation rock can affect the storage capacity of CO2. For example, if CO2 reacts with the formation rock, it can reduce the storage capacity of CO2. The next factor is the depth of the formation. The depth formation is an important factor in determining the storage capacity of CO2. The deeper the formation, the higher the storage capacity of CO2. Next, we have tectonic setting. The tectonic setting of the formation can affect the storage capacity of CO2. For instance, if the formation is located in an area with active faults, there is a higher risk of the CO2 leakage. Last but not least, we have the wellbore integrity. The integrity of the wellbore is important for the success of CO2 storage. If the wellbore is not properly constructed or maintained, CO2 can leak out of the formation.
Now, now we move on to the potential benefits of carbon dioxide sequestration of sedimentary basin in Malaysia. So the first one, we can reduce the greenhouse gas emission. Carbon dioxide sequestration helps in reducing the amount of greenhouse gases in the atmosphere, which is crucial for mitigating climate change. Then, we can supporting climate change mitigation, as developing countries like Malaysia have seen a rapid increase in emission due to economic growth. Carbon dioxide sequestration can contribute to global effort to mitigate climate change. The third one is enhancing energy security. Given Malaysia's status as a natural gas producer and net exporter, the development of carbon dioxide sequestration technologies can help in maintaining energy security by addressing the high content of carbon dioxide offshore gas field. And the fourth one, we can minimizing the environmental impact. The study suggests that carbon dioxide sequestration in sedimentary basin can provide a safe and effective storage for carbon dioxide, potentially preventing carbon dioxide leakage and outward migrations that could affect public perception and health. Next, there are limitations and uncertainties from these studies. The first one is the limited data availability. The study acknowledged that there is limited data available on the geological formation in Malaysia, which can affect the accuracy of the storage capacity estimates. The second one, uncertainty in storage capacity estimate. The storage capacity estimate provided in the study are based on the theoretical calculation and assumptions, which can introduce uncertainties in the actual storage capacity of the sedimentary basins. The third one is lack of field validation. The study is based on a desktop analysis and lacks field validation, which can affect the accuracy of the results. And the fourth one is economic and policy uncertainties. The study does not consider the economic and policy uncertainties that can affect the deployment of carbon dioxide sequestration project in Malaysia. So, as the conclusion, the study successfully identifies the potential storage sites and assess the carbon dioxide storage capacity within the deep saline aquifers in Malaysia, providing the valuable insights into the country carbon dioxide sequestration potential. The second one, the study ranks 14 identified sedimentary basins in Malaysia based on their potential for carbon dioxide storage, which with the Malay Basin, Central Lusonia Province, West Baram Delta, and Balinian Province identified as the top candidates for carbon dioxide storage. Approximately 27% of sedimentary basins in Malaysia were evaluated as high potential area for carbon dioxide storage, indicating that there are significant opportunities for carbon dioxide sequestration in the country. That's all from us. Thank you.